Math?
Yes.
What the heck? Oh, I see what went on. Isn't math the only meet we have today? Because it's Friday.
Probably.
We have one at 2 o'clock. No, we have one at 2 o'clock because we have an author meet.
Oh yeah.
Okay.
Yeah, thank you.
Okay. Yeah, I think normally math is the only one that you have on Fridays, but we'll see. Probably like, I don't know when Mrs. Jowett's setting up those off their meets, but.
Mr. Reed, I just wanted to let you know that I'm here.
Who's that, Gavin?
Yes.
Okay. Thank you.
I am also here.
Is that Adam?
I have been here.
Yes. Yep.
It's pretty good. I can't see the screen when I'm presenting. I don't see your guys' faces, but I am starting to recognize your voices pretty good. So beware when we get back to school and you think no one can see you, but you say something. Because now I know your voices.
No, that's not good.
Okay, so this chart that I put up here, this is a horse. Someone went on a horseback ride, and I'm sorry, they went on a trip. This is the number of trip, and this is the number of students. They went to a stable to go horseback riding. But the first trip, they had 15 students go on it. The second trip, they had 16. The third trip, they had 18. Fourth trip, 21. Fifth trip, 25. The question posed is there a constant rate of change throughout this graph? So when we look here and we say this goes up by 1 and this goes up by 1. This one goes up by 2, but this one continues to go up by 1. And now we're going up by 3, and this one goes up by 1. And now we're going up by 4, and this one goes up by 1. Because these numbers aren't the same, it's not a constant rate of change. But there is some kind of a pattern here. So the pattern would say that if I look at these numbers, 1, 2, 3, 4, what do you think the next one will be? Probably be 5, and we would probably go up to 30. And because this one up here was staying constant, the pattern would say that the 6th trip, there's 30. The 7th trip, there is 36. The 8th trip, there is 43. The 9th trip, there would be, I can't concentrate because my dog's down here snoring. You guys probably can't hear him, but he is. And so on. So we have a pattern occurring, but we don't have a constant rate of change. We're going to start looking at sequences of numbers. And a sequence of numbers is an ordered list where each term I should say where each number is called a term. And there's special types of sequences that we're going to talk about. The first one normally that word is pronounced arithmetic, but when we're talking in terms of sequence, it's called arithmetic. An arithmetic sequence is a sequence where the terms go up by the same amount. And we're going to refer to that same amount as the common difference. And we're going to use the letter D to represent the common difference. So this one, this example up here of the trip, there's a pattern, but it's not an arithmetic sequence because it doesn't go up by the same amount each time. Let's look at this. This is a list of numbers that go on because we have the dots afterwards. And when we look at those list of numbers, is there a common difference between each one of them? What do I have to do to go from 8 to get to 13? I add 5. From 13 to 8, I add 5. From 18 to 23, I add 5. So there is a common difference. So this is an arithmetic sequence. Could you tell me what the 10th term in that sequence is? So this is the first term here. This is the second, third, fourth. Can we continue the pattern? Fifth, sixth, seventh, eighth, ninth, 10th. So the 10th term is 53.
I was doing it.
Okay, good.
You didn't have to be doing it.
Okay, so we're just continuing the pattern of adding 5 each time until we get to the 10th term. Now, are you going to want to do that if I ask for the 1000th term?
No.
No, you're not. No, you're not. So in order to do the 1000th term, we're going to create an expression that represents our arithmetic sequence. And that expression is, where do we start at? We're starting at 8. So that kind of goes back to that car rental. There's a certain amount that we start with. We start at 8. We add on a common difference of 5. And how many times do we add that 5 on? Well, for the first term, we don't add it on at all, right? So for the first term, there's 0 added on. For the second term, there's 5 times 1 added on. For the third term, 5 times 2. So can we represent, is there a way to represent using a variable for the term number and how many 5s we add on? Look at the pattern between there, 1, 0, 2, 1, 3, 2. How do I go from the 5th term to know how many 5s I add on? What do I have to put there?
1,000?
No. For this one right here, no, definitely not, because I'm only looking at the 5th term. So for the 5th term, what do I put in here? Look back up at the first term.
I think.
Did I hear 3? Is that what you were saying? If I
said 5.
Okay, it's not going to be 5. If we go and we say, okay, the first term we added 0. The second term we have 1 5. The third term we have 2 5s. The fourth term we would have 3 5s. The fifth term we would have 4 5s. The sixth term would be 5 5s. So what's that relationship between the term number and what's going to go in that parentheses? So in the x term, how many 5s am I going to have? X minus 1. Do you see that if I go from 1 minus 1 is 0, 2 minus 1 is 1, 3 minus 1 is 2, 4 minus 1 is 3, and so on. So the x term is going to be x minus 1. So for the thousandth term, what am I going to put in here? I'm going to put in 1,000 minus 1, or 999. Am I losing you? Did you stay with me? Do I need to go over that again?
I'm there.
Okay.
Yeah, I'm there.
Okay.
I just need to finish writing it all down.
Okay. So for the thousandth term for this sequence of numbers, it's going to be 8 plus 5 times 999, which comes out to be 5,003. So in general, for this sequence, if I ask for any, I'm going to use this, nth term, it would be whatever I start with, in this case 8, plus my common difference, in this case it's 5, times the term I'm looking for minus 1. Okay, you guys got that written down? Is it all right if I go on to the next page?
Yeah.
Okay. Okay. Is there a common difference in this sequence?
Yes.
Yes. We're going to add 13 on each time, right? So each time we add 13 on, we start, if we want to talk about in general for the nth term, we say we start with the starting one, which is 0, plus 13 times n minus 1. Does that 0 have any play into the equation anymore? No. So if I'm looking for the 20th term, I'm going to find that by just calculating out 13 times 19. It's always going to be one less than the term number that you're looking for. So the 20th term is going to be 247. Now you could take the time to go out and add 13 on 20 times, or you can look at the formula. Can you tell me what the next 3 terms in this sequence are going to be? So if I'm at 39, I have 0, 13, 26, 39. The next one's going to be 52. The next one's going to be 65. And then the next one's going to be 78. So 52, 65, and 78 are the next 3 terms in that sequence. Is there a common difference?
Yes.
Yes, you add 3 on each time. Next 3 terms, 16, 19, 22. Is there a common difference?
Yes.
What is it?
Yep. 3.
-3.
Negative 3, yes. So our common difference can be negative. And then we just continue the pattern. So the next 3 terms in the sequence are going to be 1, -2, -5. So your common difference does not have to be the same there. Can we look at decimals? Does our common difference have to be whole numbers?
I guess not. I mean, if you're doing it, I guess not.
So what is the common difference here? From 2.4 to 3.2, we have to add on
8.
0.8. 0.8, 0.8, 0.8. To get our general term, our starting one would be 2.4 plus 0.8 times n minus 1. And that would be for the nth term. So, your assignment. About page 361. 1 through 8. (16) through 26.
Mrs. Reed,
Yes.
will you post the assignment on Google Classroom so I can print it like yesterday?
Yes, I will. Yep. I will do that. Any other questions?